Welcome to Saitechinfo channel, my dear students. In today's session, we will discuss the electrochemical extraction, where we will be discussing about the extraction of aluminium by Hall-Herold process. Now let us explain about the principle behind the electrochemical extraction. Metals have the tendency to undergo metal oxide very easily by oxidation. And the formation of oxide layer over the metal is called the rusting process, as in the case of iron. You can notice as the brown rust. And a white rust is formed on aluminium. So aluminium oxide. Now our idea is making use of this strategy. We want to remove the metal from the metal oxide which has naturally been formed. So these metal oxides are available as metal ores. So this metal oxide can be easily reduced sometimes. Sometimes it requires sophisticated process. So generally metals can be of two types, that is reactive metals, non-reactive metals. The metals which are reactive have the tendency to form metal oxide quickly, and it would be very difficult to extract such metals from the metal oxide. So in that case we use the electrochemical process. And there are some metals which are non-reactive. So such type of metals, by using some reducing agent like carbon, they can be metallurgically processed by using some reducing agents. So such type of metallurgical process can be achieved by thermodynamic reduction. But in the case of reactive metals, we need to use the electrochemical reduction techniques. And before getting into the extraction of a particular metal, as in the case aluminium, let us look into the principle. The feasibility of the reaction is expressed as the decrease in free energy. What is free energy? It is the available form of energy. So the free energy change should be negative for any natural reaction, for the reaction to proceed. So it can be interpreted as the feasibility of the reaction. So you can say when delta G is negative, then there is a feasibility of a reaction. So there is a relationship between this thermodynamic property and electrochemical property. Minus delta G is equal to NFE0, or it can be called delta G is equal to NFE. Now we are studying at standard state of temperature and pressure. So we can put the naught, delta G naught. Likewise E naught, the cell EMF at standard state, STP. So minus delta G, we can bring this minus to this side. So minus delta G is equal to NFE naught. Therefore, the minus delta G represents the the feasibility of the reaction. Similarly, the positive value of E naught, that is cell EMF, indicates the feasibility of the reaction. You understand this? So based on this concept, we are proceeding further. Now, let us look into the extraction of aluminium. So it is called the Hall-Herold's process. So whenever you discuss about the extraction of any metal, there are 5 important things you must note down. Apart from that, there should be a neat diagram. So you can roughly draw a diagram representing the entire electrochemical setup. So this electrochemical setup consists of, you must say, the electrolytic bath, and what is cathode, what is anode, what is the electrolyte, then what is the electrodic reaction. So all these five should be clearly mentioned. Now let us consider the first one, the electrolytic bath. So it talks about the bath, how it is constructed, fabricated. So this is an ion tank in the case of Hall-Herold's process, duly lined with carbon inside, and that lining itself acts as the cathode. When you move up to anode, we need to suspend the carbon blocks as anodes. Then we have to pour the, that is electrolyte. What is electrolyte? Electrolyte can be an acid or base or salt, that is in solution form or in molten form, but the condition is it should conduct electricity. So in this case, what is the electrolyte? 20% alumina, 10% calcium chloride solution, and then you have to add the molten cryolite, that is the O. So with all this, we make up the electrolyte and the electrolytic bath. It's called the electrolytic bath. Now we have to introduce the sufficient current, the required current here. So after introducing the current, what happens here? Electrochemical reaction takes place. So what do you mean by electrochemical reaction? It consists of the cathodic reduction and anodic oxidation. At cathode, what occurs? Reduction occurs. What do you mean by reduction? Addition of electron. At anode, oxidation occurs. So what do you mean by oxidation? In terms of electron, de-electronation oxidation. Now let us look into the reaction. You just go through that. In this case, we have at cathode, that is aluminium ion. It's a trication, is it not? Aluminium 3 plus. That undergoes, being cathode, reduction. Reduction means what? Electronation. So 3 electrons are added. So that is why it is indicated as reduction. So when you put H within bracket, that indicates reduction. So that becomes aluminium. Okay, so this is the half cell reaction, or it can be called the cathodic reaction. Now let us move to anode. At anode, what kind of reaction takes place? That is oxidation occurs. So we have carbon electrodes, and this undergoes reduction, I mean oxidation. So addition of oxygen and removal of electron here. So it forms a carbon dioxide. Okay, carbon dioxide. Now we have 3 electrons reacted at cathode and 4 electrons that is produced at anode. That should be balanced. So it has to be removed first of all. So in order to remove that, we need to balance it. So find out the LCM between 3 electron and 4 electron. What is that? 12 electron. So in that case, the first reaction can be multiplied by 4. The second reaction can be multiplied by 3. Now 4 aluminium 3 plus, okay, 4 aluminium 3 plus, and 4 into 3, 12 aluminium, I mean electron, 12 electron, then 4 into Al, that is 4 Al. Now we have got, and this must be, second reaction must be multiplied by 3. So 3 carbon, is it not? So we have written 3 carbon, and 3 twos are 6 oxygen, so 6 oxide anion, and 3 CO2, so we have put 3 CO2, and 12 electrons, so we have already 12 electrons. Do you understand? Now we need to remove the electrons, because 12 electrons on LHS and 12 electrons on the RHS, so that can be striped out, that is removed. Now the remaining is 4 aluminium 3 plus as the melt part, then plus carbon, 3 carbon plus 6 O2, that gives 4 aluminium and 3 moles of carbon dioxide. So that is evolved as gas. Now you are able to get the what? Aluminium at anode. You understand? So this is the way we get the pure aluminium by this method of electrochemical metallurgy. So do you understand? So as far as the electrochemical process is concerned, you must once again that is look into that. That is, you have to draw the diagram neatly and establish all these five important features. That is, electrolytic bath should be clearly mentioned here. Okay, and the cathode, what is the cathode, what is the anode, and what is the electrolyte, then what are the electrochemical reaction. So the electrochemical reaction should be neatly balanced. Are you able to understand? So if you have got any doubt, you can leave your comments in the comment column given below. Okay, so thank you very much for watching this video.